Welcome. This video is to expose the mistakes that students make when plotting their physics practical graph during examinations. As an examiner of many years' experience, these are recurring mistakes every year, leading students to loss of marks and even failures. So make sure you watch this video to the end. Like, subscribe, and also share. You are welcome. So we are going to use this table of value. This is the table of value for electricity experiment, where the current is taken as well as the voltage. You can see the reading of the current taken increasing downward, as well as the voltage also increasing downward. Now, what are the common mistakes that students do here? If you look at the column for current, after the current, the unit is written in bracket, that is ampere. Some students, they omit this. And if you look at voltage, the unit is written in volts. Now, when quantity are written and such quantity have a unit, student must put those units in front of those quantity. Not all quantity have units anyway from graph, but when you have quantities that have units, student must write those units in bracket in front of those quantity. If they don't write it, they lose marks. That is one. Then secondly, when you look at the table of value, you see that the marks, the values were recorded to 2 decimal places, right from number 1 to number 6. So you're having 0.30, 0.60, 0.90 for current, not 0.3. And you come to the next one, you write 0.60, which many students make. All of them are in 2 decimal places. Also for voltage, they are also in 2 decimal places. So when you are recording, if it is 2 decimal places, you must be uniform all through. Not to record one in 2 decimal places, you go to the next one, you record in 1 decimal places. Yes, these are what we see every year. If you look at, for example, the voltage, we have seen where students will just write 0.3 and go to the next one value for voltage, which is the second reading, they write 0.60. They come down again and write 0.9, like that. So these are common mistakes students must correct and make the necessary and write their volume very well. Students should also check. You see, if you look at this reading, current there is increasing from 0.3 and it's increasing downward. So that means if you look, you see these values are correct. Not that it is increasing downward and later decreasing again. You know, when you see that, you know there is a mistake. So when practical values are increasing, they will increase downward, especially when we are talking about linear graphs. So you see the value always increase, or the straight line graph increase downward or decrease downward. So not that it increases and decreases. So when you as a student, you see your value increasing, then later decreasing, then you know there's a mistake. So you quickly check where the mistake is and make the necessary correction. And in this graph, we are asked to plot a graph of current, that is I, on the vertical axis and V on the horizontal axis. Plot a graph of current, that is I, on the vertical axis and V on the horizontal axis. And when plotting your graph, When plotting the graph, there are things you must include in your graph. Very, very important. One, you must include the title of the graph. Then you must draw your axis and label the axis. You must draw your axis and label the axis. Then you must look and use a suitable scale for each of the axes. Use a suitable scale for each of the axes. And you should use a scale that will at least make your plotting or the graph occupy even more than half of the sheet, the graph sheet. Then number 4, you now do your plotting. Do the plotting of each of the points. Then after that, number 5, you draw your line of best fit across your points. Then you look for the slope and every other necessary questions as required. Now, the title of your graph. That number 1, the title of your graph is very simple. The title of your graph is what you are plotting against what. For example, now they say we should plot current. From this, now they say we should plot current against voltage. So here now, the title of our graph now will not be a graph of current against voltage. I think that is clear. This is a graph of current against voltage. So whatever they say you should plot against, use that to form your title. So here is a graph. This is a graph sheet. So having our title of graph, which is a graph of I against V with their unit in bracket. So we are using 4 centimeter here to represent 0.3 unit on the vertical axis, that is the current axis, and using 2 centimeter to represent 0.3 unit on the horizontal axis, that is the voltage axis. So when you spread that across, you see 4 centimeter to represent 0.3 unit on the I axis and 2 centimeter to represent 4 units. And 2 centimeter to represent 0.3 unit on the vertical, we are using 0.2 centimeter to represent 0.3 unit on the horizontal axis. The scale of our graph is that, write it on top. See where I've written it, the scale of the graph, where I've placed the title, write it there at the top right corner of the graph sheet. This is where you write the value of your scale. Then the axis that I've drawn, we call it labeled axis. So after drawing the lines, you label it. So we are using 4 centimeter here, starting both axes from 0. So from here to here is 4 centimeter, that is 0.3, 0.6, 0.9 at every 4 centimeter, 1.2, 1.5, 1.8 like that. Then on the horizontal scale, we are using 2 centimeter to represent 0.3 unit. So from here, from the 0, from that place, this 0 to here is 2 centimeter, which is 0.3. Another 2 centimeter, 0.6, 0.9, 1.2, 1.5, 1.8, and so on, like that. See, labeled axis. And here also V, the unit, also written in bracket. That's what we call labeled axis. So students make the mistake. Some people don't even write the quantity, talk less of writing the unit. So you must write the quantity and the unit on the axis. Using the axis must have a pointer arrow. Using a pointer arrow, please take note. Please take note, and must be leaded. You don't just draw axis, plain axis, and leave it. So these are area where students lose marks. If you look at the graph on the y-axis from the 0 mark to the 0.3 mark, that is 4 cm, we have 20 lines in between. So we must get the value of one line before we can do any plotting. For us to get the value of one line, since we have 20 lines in between, we just say 0.3 divided by 20, and that will give you 0.015 units. 0.015 unit. That is the value of one line on the vertical axis. So you must find all this before you can do any plot. That is the value of one line on the vertical axis. While on the horizontal axis, we are having 10 lines from the 0 to, so that will be 0.3 divided by 10. That will be 0.03.
Now that we have known our
divided by 10, that will be
points,
0.03.
Point of the value of
0.03. So one of the line
vertical
here is 0.03. So these are what we are going to do
plotting.
before you can even
if you look at our table,
your
table
points,
of value,
you know the value of each of the lines
current is
in each of the axis.
0.3.
So if you don't know this, you wouldn't be able to plot your graph.
0.3 also. So we trace it.
It's very, very necessary.
Mark it.
By just dividing the value, divide by.
The voltage is also 0.6. So we also indicate the point there using a very thick dot. You can use a star, you can use plus, you can use dot. But here I'm using the dot point. So I'm using the dot point here. When it is 0.9, 0.9, you can see from our table, the voltage is also 0.9. That is 0.9, it's also 0.9. So you locate the point very neatly. Look at it. Here the 2 point means 0.9 meeting 0.9. I think this is a very simple one. The next one, 1.20. So meet 1.20. And the voltage axis. So that is the location. So this is the location. Put it there. Then when it's 1.5 on the current axis, it's also 1.5 on the voltage axis. And the last one, when it's 1.8 on the current axis, it's also 1.8 on the voltage axis. So this is the location. You can see our point. We have a very, very straight line there. Very, very straight line there. So we join all. So we join all the point together with the straight line, as you can see. That is my line of best fit. That is the line of best fit. And here is really taking all the point, passing through all the points. At times it does pass through the points. Maybe pass through, at least we pass through three points. Now for calculating the slope, we have to draw a very big triangle. Let the distance be wide, very, very wide apart for a good accuracy. So the bigger your triangle, the better. So I'll be taking it from this point. I'm going to draw my triangle down. That's a big one. And I'm taking it down, then bring it to this point where it meets the line. And that's a big triangle. So taking it from that point and to this point. So you can see, yes, I've drawn that using my ruler. So you use a ruler to draw that. Now, this point will be current 2. Here will be current 1, since it's increasing upward, because that line represents our current axis. While this one, the horizontal axis, since it's increasing, this will be the V2, while this will be our V1. So our slope now, the slope of the graph x will be equal to I2 minus I1 over V2 minus V1. So we'll now read the value from the graph. So the slope of the graph is I2 minus I1 over V2 minus V1, where your I2 is 1.5 minus your I1, which is 0.15, divided by V2. From the graph, our V2 is 1.5 minus our V1, which is 0.8. When you subtract the 1.5 minus 0.15, you are going to have 1.35 for current. Then when you subtract 1.5 minus 0.8, you are going to have 1.32 for the voltage. And when you divide that, you have a value of 1.023 ampere per volt. Ampere per volt. Since the top one, which is current, your numerator is, the unit is current, which is ampere. The unit is ampere. While the divided by your voltage, which is the unit of voltage is volt. So the unit of your slope will be ampere per volts.